All right, we are continuing with our Unit 1A packet, and we are on the last topic of Unit 1A, which is topic number 5, modeling with expressions. The key here is that we are going to write our own expressions. That's why it's a little bit different than what we've been doing so far. So we're going to start right away with example 1. So I'm just going to read this with you. Example 1 says, Dessa says, I chose a number, I multiplied it by 7, then I subtracted 4. Let D stand for Dessa's starting number. Write your own expression for Dessa's ending number. The key thing I want you to recognize here is that it says, I chose a number. That's the only thing. It says, I chose a number, any number. We don't know what number Dessa chose. That is why we need a variable to represent that number, because I don't know what it is. Every other part of this problem, we were given details. Multiplied by 7, subtracted 4. The only part that's unknown is what number did Dessa start with. All right, so we are going to, in order, write this expression, just by the steps that she took. So first she says, I chose a number. We're going to just write the letter D here to represent the number that she chose. Then it says, I multiplied that number by 7. So I want you to think about how you could write multiply by 7. We have lots of different ways to write it. I'm just going to keep a list over here. So multiply by 7, we could do this. D x 7, that means multiply, right? You learned that when you first multiply. We could do D dot 7. We could do D parentheses 7. Or you could just do the 7 right next to the D like that. These all mean multiplication. So I'm going to actually choose the one that is most mathematically correct. They're all correct, but the one that's most commonly used by mathematicians is this one right here, 7D. If you wrote any of these other options, that's correct. But just since this is your notes, I'm going to use the one that you're going to see most often when you are looking at math materials. So I'm going to write 7D, which means I'm going to put the 7 in front of the D. And that literally means I chose a number, I multiplied it by 7. All right, so multiplied by 7, we did that part. And then it says, then I subtracted 4. So at the end of this, I'm just going to write minus 4. And this is an expression. We are done. That is our expression. If I plugged something in for D, I would be able to figure out what the ending number was. All right, we're going to start here with example 2. This is about Chris. It says, Chris says, I chose a number. Again, this is a mystery, what number he chose. I subtracted 4. Then I multiplied by 7. Sounds really similar to what Dessa did, but the order is different. So we're going to have to make sure we pay attention to that. This says, let C stand for Chris's number and write an expression. So I'm going to start the same way with just a big C here. And let's think about, this is the number that Chris chose. This is where we start. Chose a number. Next, he subtracted 4. So starting number, C, I'm just going to write minus 4 here. Then he multiplied by 7. So let's think about this. If I just put a 7, I don't want you guys to write this. If I just put a 7 out front, it would look just like that one. But we know that's not what he did. He did these steps in a different order. So I don't just want to put a 7 out front. What I want to do is I want to think about how can I show that I want to do this step first. And how we do that is we are going to use order of operations. We are going to use a grouping symbol. So what I'm going to do is I'm going to put C minus 4 in parentheses. I'm going to erase this little thing. So this means this is telling the person reading this that you should do this step first. Subtract 4 first. Then multiply by 7. So then I'm going to put a 7 out front like that. I could put a little dot there. You could also this would mean exactly the same thing. Put C minus 4. You could also do times 7 at the end. That might seem more natural. That's fine. These are both correct. All right, so we're continuing with these examples. Example 3, now we're talking about Maya. So this says Maya has 6 fewer unopened Snapchats than Nora. That means Maya has less Snapchats to look at in her phone. So I'm just going to think about the word fewer and what that means. It means less, right? And if you think mathematically what that means, that should make you think about subtraction. If you have something fewer, it means whatever Nora's has, we're going to have to subtract. And then it says complete the table to show the relationship between the number of Snapchats. All right, so the top row is Maya, right? And Maya has to have fewer or less Snapchats, which means this number down here is always going to be bigger than this number up here. All right, so number of Maya's Snapchats is 11. If she has less than Nora, it means Nora has to have more. How many more does she have? She has 6 more. So I'm going to write here 11 plus 6, and that's 17. So Nora has to have 17. All right, here's this one. Maya has 20. And we know that Maya has less than Nora, right? Nora has more. She has 6 more. So this time we have 6 more than 20. That is 26. All right, let's go to this one. This time we're starting with Nora. Nora has 23. And we know that Maya has fewer, 6 fewer than Nora. So what we're going to do up here is we're going to do 23. That's how many Nora has. She has more. And we're going to do 6 fewer, which is subtract 6. 23 minus 6 is 17. All right, if Nora has 8 Snapchats, Maya has to have fewer. She has to have 6 fewer, minus 6. That means Maya only has 2 Snapchats. All right, now this next one, we have a letter. We have the letter M. So that means we don't know how many Maya has, but we know that she has fewer than Nora. An easier way to think of that is that Nora has more. How many more? 6 more. So that means however many Maya has, M, Nora has 6 more than Maya. M plus 6. The next one we're starting with Nora's. We don't know what N represents. It could be any number. And if Nora has N, I know Maya has to have less. How many less? 6 less. Whatever N is, minus 6. All right, so in the next problem, we're going to talk about Jimmy. And it says Jimmy went to Subway to buy lunch for his friends. Salads cost $6. Wraps cost $5. And I'm just going to make a note here. Let's say, see how there's an S and a W over here? Let's talk about what that means. So let's write S equals the number of salads that Jimmy buys, and W equals the number of wraps. That's what S and W is supposed to mean. So for the first part, we're just going to make up what could possibly happen. So if Jimmy was going to Subway to buy lunch for his friends, let's pick a reasonable number of salads that he might buy. I don't know, maybe like 3 salads. What if Jimmy bought 3 salads and maybe like 2 wraps? That's an okay scenario. That means he has 5 friends total, because 3 plus 2. All right, so he bought 3 salads and 5 wraps. We're going to try to figure out how much money he spent. So I know that salads cost $6. So that means that $6 per salad, and Jimmy bought 3 salads. All right, and that's only the cost of salads, so we're going to add to that the cost of the wraps. Wraps cost $5. Jimmy bought 2 of them. All right, so that means his total cost is, let's do this math. 6 times 3 is 18, plus 5 times 2 is 10. So in this case, he spent $28. All right, let's do the next one. Let's just pick another random number of salads and wraps. What if he bought, I don't know, 4 salads and only 1 wrap? All right, so in this scenario, we would do, okay, salads cost $6. He bought 4 of them. Wraps cost $5. He only bought 1 of them. So the amount of money he would spend would be 6 times 4, that's 24, plus 5. In this case, he did 24 plus 5, that's $29. All right, so in this last space right here, I'm just going to write, I don't really have room up there, so I'm going to write it right down here. It says expression for the total cost. Expression means that I'm going to have variables in my total cost. I want you to look at these 2 rows that we just did and see what they have in common. Do you see how they both have a 6 and a 5? A 6 and a 5? They actually both have these parentheses. And the only thing that changed is what number we plugged in to the parentheses. That's a really big hint. We're looking for that type of thing. So when I write my expression, I'm going to write it like this. 6 and then a parenthesis. And we'll talk about what's going to go in the parenthesis in a second. Plus, the other thing they have in common, remember, is that 5 and then a parenthesis. Now, what should go in those parentheses? What should go in those parentheses is how many salads, which we know is S, and the other one is how many wraps, and we know that's W. And this is our final expression. And that means that we can plug in any number for S or W to figure out how much money Jimmy spent. What's going to go in the All right, in our last example, we have this taxi cab example. So, in this taxi cab example, it says a taxi cab charges you $5 to pick you up, and then 25 cents every quarter mile that you travel. And this company also charges 50 cents for every minute you spend stuck in traffic. Now, this actually is pretty much how taxis work. They charge you for how far you're going, that's every quarter mile. They also charge you for how long it takes. So if it takes a really long time, that taxi driver is going to get more money because it's taking him more time to take you to your destination. All right, so we're going to just pick some numbers to put over here, and let's think about, what do you think Q stands for? Q stands for every quarter mile you travel. The M stands for every minute you spend stuck in traffic. So this Q, the quarter miles, we're going to get charged 25 cents for every one of them. The M, we're going to get charged 50 cents. So I'm just going to start by picking some numbers, okay? So I'm just choosing these numbers myself for you guys, okay? So you could pick your own, but I'm going to pick some that we're going to work out just to make this a little bit easier. So I'm going to say, what if in the first scenario we went 8 quarter miles and we were in traffic for 10 minutes. And in the second one, I'm going to make this up, we did 12 quarter miles and we were in traffic for 20 minutes. And in the last one, we drove 16 quarter miles and we were in traffic for 30 minutes. So we're just going to play around with those and see what happens. All right, so let's try to think about how much money this taxi driver would charge you. So to start, I'm just going to write here 5 plus for every one. Why do you think I'm writing 5 plus? If we reread this problem, it says a taxi driver charges $5 to pick you up. So that means that no matter how far you're going, this doesn't matter at all. You are always going to get charged $5 just for that driver to pick you up. So I just started by writing 5 plus so we don't forget. All right, so I'm doing 5 plus, and now you get charged 25 cents, so 0.25 for every quarter mile. So I'm going to multiply this by the number of quarter miles, which in this case is 8. And then you're going to add to that 50 cents, 0.50, times the number of minutes, which is 10. Now you might need a calculator to do some of this work. I am going to scribble this out because I'm going to need some more room. I'm going to put my answer right here. I need a little bit more room. And if I do this in my calculator, if I do 0.25 times 8 and 0.50 times 10 and add these and add them to the 5, I'm going to get $12. It's going to cost $12. And you can check that on your calculator if you want. All right, we're going to do the same thing now. I'm going to just switch colors so we can see with 12 and 20. All right, so this taxi driver charges $5 just to pick you up. Then we add to that 25 cents. This time we traveled 12 quarter miles plus 50 cents for 20 minutes stuck in traffic. And if we actually do this math out, you'll get $18 for this one. And then I'm going to do the last one, $5 just to get picked up, plus 25 cents. This time we traveled 16 miles, plus 50 cents for 30 minutes. And if you do the math out for this one, you should get $24. So this makes sense when we are in the car for longer trips and for more minutes, we have to pay more to the cab driver. Now I want to look and see at these 3 sets of calculations, same thing we did last time, see what stayed the same. And look what stayed the same, 5 plus. That never changed. The other thing that never changed is this 0.25, 0.25, 0.25. And the other thing that never changed is 0.5, 0.5, 0.5. The only thing that was consistently different was this little section right there. So I'm going to undo that so it doesn't mess us up. But now I'm going to write an expression. So I crossed off where it says expression because I ran out of room. You might need to do that too. I'm going to write an expression right here. And the expression is everything that didn't change. So my expression is going to be 5 plus 0.25. I'm going to put a parenthesis. And then I have to go to the next line, plus 0.50 and a parenthesis. And what goes in the parenthesis here is the part that we did change. So the number that went in the first parenthesis was our Q, and the number that went in the second parenthesis was our M. And this is our expression. I'm going to write it right here just so it's all on one line. 5 plus 0.25 Q plus 0.50 M. All right, you have some practice today for your classwork and also for homework. Good luck.